Jonathan Blow versus Bret Victor, a trade-off between entertainment value, rigor, and real-world applicability in explorable explanations and games. Because why not? I mean, the line is blurry, but anyway. So I'm going to be talking about these two. I'm just going to check. Yeah, you can see that. Jonathan Blow here on the left, Bret Victor on the right. If you want to hear more about them, or sort of the source for a lot of this talk is coming from Jonathan Blow's talk, Designing the Universe, and Bret Victor's very interesting explorable explanation called Up and Down the Ladder of Abstraction. Strongly recommend both of these. You can't infer everything about them from these two particular things, but they're two pretty smart people, so, you know, there's other stuff out there that they've made, and strongly recommend looking it up. In summary, this talk is sort of I want to move about how I want to move my work to being in the mode of Jonathan Blow, having previously made explorable explanations in the mode of Bret Victor, in a strong sense. I believe that if I move in this direction towards being more Blow-esque in the things that I make, I will produce content that is more rigorous in the things that it says. It'll be easier to follow, potentially, and it'll be more enjoyable. And to be clear, both the thing that these folks have in common, in some sense, they're both software developers, and they're both trying to express things to you. You'll see what I mean by that. And they're two smart folks as well, and I feel like we've sort of just invented the computer as a society, and if humanity sort of survives much longer, then computers will become more and more a part of how we express things to one another. And it's kind of an important moment. I'm not exactly saying that Jonathan Blow and Bret Victor are sort of going in exactly opposite directions. It might be something like this. I think it's important. And another thing, I don't want this to be about personality. I've got two personalities sitting here on this slide. Both of these people might eventually feel like I've misinterpreted them and will get annoyed at me. I hope that doesn't happen. But even if they disassociate themselves from what I have said about them in this talk, the thing that I'm saying will still hopefully be meaningful. If they both disassociate themselves from what I'm saying, then maybe instead of talking about Jonathan Blow and Bret Victor, I can talk about Alice and Bob, two imaginary developers of explorable explanations. Also, by the way, designing things more like Jonathan Blow will mean that I will use fewer words and I will talk about the physical world less. And all of these things are correlated. Rigorousness, easiness to follow somebody's argument, enjoyability of their argument in this explorable explanation context, using fewer words, and talking about the physical world less. So, yeah, and the structure of this talk, first I'm going to sort of compare them directly, Jonathan Blow and Bret Victor. In part 2, I'm going to talk about how it's important to have the rigor that Jonathan Blow brings to his work. Part 3, Bret Victor's freedom, in a sense. And in part 4, I'm going to talk about art that speaks true, which is a bit arty-farty, but you'll see what I mean. And it's generally about expressing true things through entertainment. So, I'm adopting the convention that Jonathan Blow stuff goes on the left. I can't remember whether the Twitch video of me... Okay, Jonathan Blow stuff goes on the left, and Bret Victor stuff goes on the right. Here's a platformer called Abe and Hawkins and the 1000 Spikes. It's very fun. It is, in some sense, in Jonathan Blow style. It is one of his favourite games of all time. In Abe and Hawkins, it is a platformer and it is incredibly constrained. There's pretty much no difference between seeing someone successfully complete a level and seeing someone speedrun a level. Everything that happens is the same. And it's an incredibly good game, and because of that, it allows you, the level designer is able to express very, very specific things to you. This is why Jonathan Blow and myself, I like it very much. Yeah, strongly recommended. And Aben Hawkins shows you things, right? It has a specific thing that it wants you to go through, and you definitely won't complete the level without being shown that interesting thing. On the right here, we've got Apparatus, which is an interesting piece of software. Apparatus is very freeform. It lets you make your own tools. It allows you to explore stuff. These are very different kinds of things. Like in this thing, a very specific set of designer-intended things will happen, and in this thing, anything can happen. You're free to explore. This is not Apparatus is not exactly an It's not an explorable explanation, but it's sort of in the direction that Bret Victor sort of likes to go. Jonathan Blow and Bret Victor use two different methods to express truth to you. With Jonathan Blow, you have a lot of non-verbal communication, and you want to be shown something, as in Aben Hawkins and 1000 Spikes. With Bret Victor, it's not just non-verbal. Any kind of communication is allowed. Words, pictures, having tables of data, and you want to explain some particular thing. With Jonathan Blow, here's what it's about. You have a set of objects. That is the game. And everything sort of stems from that. That is everything. That set of objects. That's what's being played with. With Bret Victor, the deepest insights are born not at any one level of abstraction, but in the transitions between them. With Jon Blow, things tend to stay, with Jon Blow, things are likely to stay at one level of abstraction. You have this set of objects, and that is all that can happen. In this, there's a thing here that I made called, it doesn't have a great name, but you can play it at this location. It is an explorable explanation about epidemiology, and in it I have one little thing that has a set of objects in it, and these objects have relationships between one another. They can pass the disease to one another. I changed abstraction level at one part of it. I moved on to a model of the same thing, but that has different fundamental workings. That you can't see the same objects. Like as you can see, there's no difference between these two pictures, but they're sort of supposed to be showing the same thing. That'll happen a lot in a Bret Victor style explorable explanation, because you can go up and down different abstraction levels. You could have like a bar chart showing population, maybe, versus you could have a picture of lots and lots of people. That would be two different things, but talking about the same thing, right? Which is number of people. Number of people on a bar chart, picture of lots of people. Of course, that can happen in a Bret Victor explorable explanation, but if you have a video game, it's a set of objects moving around. They are limited. That is limited. You can't get outside of that. And in addition, Jon Blow prefers to avoid having mechanics overlap. Now, when I was making this thing, the mechanics of these two things do very much overlap. They're both trying to simulate something similar in the real world, and so they both have a way of affecting the number of people with the disease. Right? There's some variable in the simulation, which number of people with the disease, and there's different things that can affect this in my two different in my two different abstraction levels. The mechanics do overlap, which Jonathan Blow does not like. Well, yeah. Okay. Comparison of values. Jonathan Blow likes games. Bret Victor likes explorable explanations and books. Obviously, Bret Victor also likes games, and Jonathan Blow also likes books, I'm sure, and maybe explorable explanations too. But they're different forms, and we'll see that there are things drawing you in different directions when you sit down to make something. in Jonathan Blow's values, a game creates interesting situations that express insights that are valuable in and of themselves. The interesting situations in the game are valuable, are interesting. With Bret Victor, you're trying to do something different. You're trying to do something specific to the real world. Bret Victor in what do you call it? A technologist's something about technologists. What a technologist can do to help out with climate change. He says, without data, models are virtually impossible. We need good tools for imagining, proposing, debating, and understanding climate change. So he's made an explorable explanation about climate change, a very good thing to do, which I'm sure Jonathan Blow would be is sort of touches his cap to or whatever. But it's a thing about climate change. It's talking about something in the real world. Jonathan Blow, his games are about things, but his games are about rather abstract things. So the mechanics of drawing lines around a puzzle. Line drawing puzzles. Jonathan Blow would have no interest in, data is something that comes from the real world. Bret Victor, stay in the real world and bring things from there. Jonathan Blow, it's okay to be inward looking with the game that you're making. It's and it's getting kind of highfalutin, but there's a strong distinction here between, there's a strong philosophical distinction between mathematics and science, and there are other words for these. So a priori versus a posteriori ways of getting evidence. A posteriori is when you look at the real world. A priori is when you look at Platonic ideals inside of your head. Theoretician versus experimentalist, two very important different roles in finding out new knowledge, and Platonist versus empiricist, two sort of philosophical positions that you can take up. And this is an illustration of Plato and Aristotle from the School of Athens. And to make this a bit more abstract, here's a bunch of different projects that sort of fill in the spectrum between Jon Blow and Bret Victor. Again, I'm going to check whether... So if I hold up my left hand... That's my left hand. Right, it's reversed. Okay, that's annoying. Well, whatever. I'll just have to remember that. So there's a bunch of projects. Over here we've got games. We've got especially games that that are a little bit like Braid or The Witness. And over here we've got some explorable explanations. And this last thing is not an explorable explanation. This is a great game called Perspective. It uses no words. It is extremely fun. It is sort of exploring this mathematical realm. Portal has a few words, and famously there is a little bit of GLaDOS's voiceover that spoils. Well, it helps you out with one of the puzzles. Whereas over here, over to the furthest end of the leftmost end of the spectrum, the most Jonathan Blow would be no words at all. Portal. This is a nice game called Dragon Box Elements. It's more towards getting towards explorable explanations, and uses a bit more words than Portal. Megakure has a little bit more words than that. And there are words that help you reflect on some of the puzzles, is my understanding. I've still not played it. We've got Velocity Raptor here, which is an excellent thing that blurs the line very much between explorable explanation. So it's in the middle ground here. Velocity Raptor is about special relativity, and it's mostly a puzzle game. It's very, very, very much like just a straight puzzle game, but there are quite a lot of words embroidering the whole thing. Parable of the Polygons is a straight explorable explanation. It's the canonical example of an explorable explanation. My project here, Virus: The Beauty of the Beast, I now feel way more words than I would like. It's particularly hard because it was about biology, but like the whole like first 5 minutes of it, there's like a tiny bit of interaction, and there was a part that I could even have made interactive, but yeah. And then all the way on the right here, this is no longer an explorable explanation, but this is a sci-fi novel. Sci-fi novels are not explorable explanations, but Greg Egan's work sort of belongs on this spectrum. He's a very interesting sci-fi writer, and if you go to his website, you can play with little applets that he's made. Like Dichronauts was this interesting... I've not read it. It's such an interesting idea. I should read it. Interesting book about a universe in which there are 2 time dimensions, in the sense that our universe has 3 spatial dimensions. You can imagine a universe with just 2 spatial dimensions. Our universe has 1 time dimension. He imagines a universe with 2 time dimensions. Sci-fi novel, but little applets that I have played with, in which he proves that it kind of makes sense as a simulation. And I'd say that, with the explorable explanations community, I want us to keep this line blurry, right? It's possible that explorable explanations can, like, completely diverge from games as a community, and that would seem sad to me. And, at some point in the future, maybe nobody can imagine a time when, explorable explanations and games used to be considered kind of similar things, and most explorable explanation people came out of the games industry. Let's keep the line blurry, and let's see this thing going on. And some things to notice, if you go towards the left, you've got fewer words, and you've got fewer things being expressed by the simulation. They all express a few things through the simulation. Okay, part 2. As a community, I'd say that we need the rigor that Jonathan Blow brings to his work. What do I mean by rigor? It's a little bit deeper than that, actually. It's to do with programming stuff. To express it very accessibly, Jonathan Blow sometimes talks about a medium that is biased towards producing truth. That's a direct quote that he said in a few talks. It's quite an interesting thing to say. He hasn't talked about it in detail a whole lot, but so there are a bunch of different mediums, right? There's YouTube videos and paintings and music and video games and explorable explanations, whatever you like. All sorts of mediums, but not all mediums are biased towards producing truth. Clearly, you can write a lie in prose. There's nothing stopping you from doing that. And you can have a lie or an accidental mistruth in a YouTube video. Down here I've got an image from a video that was made by Kurzgesagt. I really like... I'm probably pronouncing that wrong. In a Nutshell. I really like In a Nutshell, their YouTube videos. However, this particular YouTube video that they made turned out to be wrong. They made it on the basis of like 1 or 2 studies, which is a perfectly reasonable thing to do, nice scientific study, make a nice video about it. But it later turned out that those 2 studies were not completely reliable, and on meta-analysis, the whole thing that they talked about in this video, which has like millions of views, has turned out not to be true. Now, that's going to happen, right? In science, you overturn things. Wonderful that it can happen. But, yeah, there was nothing in their medium of YouTube animations that was, like, stopping them from telling mistruths. And I don't want to fall prey to that as a person who's making something like YouTube video animations about science. To get back to mediums that are biased towards truth, the whole quote is, "Games are systems running on a computer and are therefore biased towards producing truth or at least consistency." And what's meant by that, let's have the other one as well. "In games, we have to build a world that actually works. Writing a story about the fourth dimension, you are likely to get something wrong. Anyone who has written software knows how easy it is to write a bug. It's not easy. It's not easy to write a book. However, if you do write a book about like four-dimensional things, there's nothing stopping you from getting stuff wrong. Whereas in a game, like, all I can say is that I strongly feel what he's talking about here. It's writing bugs is something that you obviously you want your code to not crash, and you want your code to not produce undefined behavior, and that requires you to think through like every single like possibility within the system that you're creating. And if you're creating, so he compared his work with some of these sci-fi novels: Flatland, Stories of Your Lives and Others, and Schild's Ladder, some sci-fi novels. And in those things, like, you could describe a world in a sci-fi novel that sort of makes sense, but like, somebody could read the book and be like, oh, there's a sort of internal consistency here. There's like no reason why their economy would be so like this thing would happen. And if you write software, you sort of have an automatic thing doing that for you. To compare game creation with scientific programming. By the way, I'm sitting here in a lab that is a theoretical biology lab. I got a job I started a PhD in this area because I was interested in exploring that. Scientific programming is when you write programs that simulate some system that you're interested in, and it's really quite like having hung around with in this community for a while, I really do think that Jonathan Blow style game creation is kind of similar to scientific programming. And yeah, to hammer this thought home, before you teach a thing, you want to be sure of the reality of the thing, obviously, and you want to be sure of your understanding of it. So, in both of these things, game creation and scientific programming, you program a system. And as you program the system, like I was just saying with the sci-fi novel comparison, you are testing that you have an understanding of this thing that you are programming. Like, one thing, a compiler error that can happen is undefined value, blah, blah, blah. It is totally possible to make a argument of a political, philosophical, scientific, any kind of argument, and use a word that you do not fully understand. And actually, lots of good conversations that I'd say I've had come from people saying, I say something, and they say, oh, you just used that word. What exactly do you mean by that word? And it can be an innocuous word, like innocuous. What does that word mean? Well, I guess it means this sort of insubstantial, not a great big deal. And people are like, oh, I see, that's what you mean by innocuous. And a compiler actually does that. Undefined value, you've got to clarify it. And innocuous is a small example, but what if you're talking about a complicated word, like, if I say something political, then that's not a great thing to do. A word like laser, I don't know. The compiler, but don't even necessarily have to have compiled it. It can just be like, oh, you're programming the system, and you've got to clarify what this object actually is and what its behavior is. Before you do that, it can just be a wishy-washy thing inside of your head. All right. looking for a phenomenon that you want. This happens both in game creation and scientific programming. Looking for a phenomenon you want might be something like, oh, I've made a deathmatch shooter, and I really want it, like, I programmed some deathmatch shooter, and I really want it to be the case that, like, you can have a phenomenon where two people are hiding behind cover and they're both, like, just about missing one another, or something like this, but, like, if you've misbalanced your guns or something like that, then maybe that never happens, and people always go and get the grenade launcher, and there's never any stop and pop. People are just trying to get the grenade launcher, and that does area of effect damage, and yeah. Looking for the phenomenon that you want, you've made this system, and there was some phenomenon that you didn't program into the system, but you want to see it as an emergent phenomenon. That is theoretical biology, right? You're like, oh, I have some assumptions about, like, this drug, like this, this molecule and this molecule, and I'm pretty sure that, like, this molecule, if I, like, simulate them, then this molecule is going to change shape or something like that. You want to see that emergent phenomenon. You didn't program it into the system, but yeah, and you might want to see it because maybe you know that in real life this molecule does change shape in response to this molecule coming along and touching it. And if you don't see that phenomenon, then you've programmed the system wrong. So this process clarifies that the system that you were picturing actually leads to a phenomenon. Once you've got a phenomenon that you want, you might want to look for new phenomena and bugs. Like, you might want, okay, I rebalanced my deathmatch shooter such that not everybody is going for the grenade launcher, and so I do have stop and pop. But maybe, like, there's some other thing that happens in the deathmatch shooter, and I'm like, oh, whoa, like, it's really cool when, it's really cool, there's this one area of my level where there's, like, this angle, and people are, like, there's this wall at this sort of angle, and people are, like, just about coming around here, and, and really affected by whether they have the grenade launcher, and they're particularly, they're most cautious in, like, this part of the level. Isn't that interesting? You didn't program that in, but there it is. It pops up in the system, and you can, like, redesign the game to try and bring that out, like, to draw people's attention to the fact that this part of the level is super dangerous. There's a Robert Yang article about that happening in Counter-Strike, and there's a bridge that's particularly dangerous, and they actually Google it. And also, there can be phenomena that you like, right? Like that thing that I just described, and a theoretical biologist doing a simulation can be like, oh, whoa, cool. Not only does this molecule change shape in response to this molecule coming along, but also, like, it changes shape in response to some other molecules coming along. That might be something that you investigate in a real-world experiment, and that is how a lot of, like, drugs are discovered, to be clear. So there are phenomena that you find that you didn't expect, and another example of that is, like, a bug, right? You're like, oh, I found out that, it crashes in some situation, or, like, there's these two molecules and they affect one another, and they're not supposed. That doesn't happen in the real world. That's a bug in my simulation that needs to be removed somehow. And okay, all of these happen in scientific simulation and game creation in the style of Jon Blow, but these two are interesting that only happen in games and explorable explanations. You design puzzles, and to design a puzzle, is to prove that an emergent phenomenon is useful for something. So in Bray, Portal. Everybody knows the thing where you jump and you fall into a portal, and like you put another portal somewhere else, and you're falling, and so you built up momentum, and you come out of this portal, and you're able to like cross a gap or something like that. And you know, when they programmed the game, they were like, for the sake of argument, let's say that they didn't know that was going to happen. They found this emergent phenomenon. They were like, oh, it's going to be cool to have this game with like portals in it, and they programmed that. And then they're like, wow, you can use this to like get really far. Now, when they were programming Portal, it was originally called an Arbacular Drop. They could have like just made the whole game a sandbox, and like you would only have come upon that particular thing that can happen if you were like noodling around, if you were like playing the game for more than like, if you were playing the game for some time. I think everybody would agree that if you just picked it up, played with the sandbox for 5 minutes and stopped, then you might not see that thing. You might not see the fling move. But creating a puzzle proves that the thing is useful, and like, yeah, that is in some sense what explorable explanations do. We're trying to draw your attention to an emergent phenomenon and say, this thing is useful, this thing is important. And finally, there's audience interaction, in which people personally examine the existence and importance of emergent phenomena. And so this is like, imagine you pick up some book, and reading the book, and the book tells you some fact, and you don't really see why that fact is relevant to anything else in the book. Or like, you don't understand it. You don't understand this one part of the book. But like, to the author, there was a reason for it to be put in there. You just didn't understand it. There was something that was trying to be explained there. Audience interaction, the fact that the audience has to solve these puzzles, proves sort of the audience has to be proved to. The audience has to be made to understand the importance and existence of emergent phenomena. There's maybe no other way of saying it. And my goal with all of this is say all of these things, they're really excellent, right? That they are your medium, the explorable explanation, forcing you to understand the reality of something and its importance as well. All of this Okay. Moving on. Puzzles, as opposed to words, are underused in explorable explanations, in my opinion. That's why I want to use more myself. It is possible that so we in explorable explanations, we have our little simulations, we have a bunch of words. And it's possible that the simulations are the only things that people are really learning, like they skim the words. I'm afraid to say I've done that with the work of some things that I've seen posted. I just play around with the explorable explanations, and I maybe read the text on the top and the bottom of it, or maybe like I'm reading the text, but my eyes are glazing over, and I'm like, here's the simulation, here's the part where it sort of comes alive. And yeah, there aren't that many puzzles out there. There aren't many times where I'm forced to understand an emergent phenomenon in an explorable explanation. So Incredipede is not exactly described as an explorable explanation, but it is very interesting, and it does force me to understand certain things. Andy Hall's work, again, contains more puzzles than other explorable explanations, and I really like it as a result of that. Here's one little puzzle that existed in Parable of the Polygons. I really, really like it. And it's not a red herring. It really does show a sort of knock-on effect that becomes relevant to the whole end thing that the parable of the polygons is trying to express. And yeah, just one little thing, like puzzles have proof that you saw the logic of something, or that you experienced the logic of a certain idea, and puzzles can delay your progress until you've solved them, which is to their credit. Yeah, and there are things here. So these are sort of visual proofs, very interesting, and they sort of show how we might really not need a lot of the text that we're using, and we might be able to say things in the text that in a much more impactful way. Okay, and finally, don't want to spend too long on this. An idea I've inherited from Jon, I would say, is to the importance of the fact that the programmer and the designer are the same person. In a lot of video games, so this is Enslaved, which is the video game that was so awful to me that it almost made me stop playing video games. Though I'm maybe being a bit unfair of it, it's got nice things in it, but like, it was the straw that broke the camel's back for me. It was clearly the designers of the game were just like, I want this to happen and this to happen. The whole thing was basically a great big QuickTime event. There was no exploration of a system whatsoever. The designer and the programmer were different people, and that is a major problem with the games industry. Similarly, it's a major problem with here we've got Brian Cox, this is from a little documentary. Brian Cox standing alongside some particles, and there was some programmer or some artist who had to create some animation, right? We see these a lot, like documentary about physics. Oh, here's an animation of a black hole. Here's an animation of gravity. Here's an animation of forces of laws of motion, something like that. All of these animations are different from like the script writer or like the presenter, like Brian Cox. It is so wonderful that we in Explorable Explanations are both the teacher and the programmer of things. And like Jonathan Blow, I have had the experience of realizing while programming. Here's something that I made. Maybe I should. It's called, if you Google lecture inside virtual reality, or something like 6-dimensional patterns and crystals. Type that into YouTube, you'll get this thing that I made. And while I was making it, I realized there was a part where I was programming it, and I realized this. I was like, oh, I've got to have like this illustrative toy and this illustrative toy and this illustrative toy. And while I was programming them, in the first version of it, I had these all separate toys. But when I was reprogramming it, I was like, I realized a unity between these toys that gave me new ideas for ways to illustrate things. It's very valuable. Yeah, and that is linked to this idea of rigorously understanding the system that you are talking about. Brian Cox in particular does so much talking about physics, which I say is a major problem. If he was making his own simulations animations, then it wouldn't just be talking. Yeah. Okay. Part 3. You need Victor's ladder, and I've extolled the values of like puzzles and this Jonathan Blow style thing where you're like, I'm exploring like these. I'm using proofs without words, and like I'm exploring like these abstract systems. But to remind us, like, there is a good reason why so many explorable explanations use lots of words. In particular, here's an example. Biology, like I said, is awful for this. This is something about zinc. Science fact. There are 2 billion people in the world who have zinc deficiency, and this affects the brain. it affects the brain in ways that make people sometimes even angry and more stressed, and that can make it harder to teach things. This is a school in Nepal where there's believed to be very high zinc deficiency. There's an interesting story from QI about Marmite being suggested as a solution to the Israel-Palestine conflict, because in Israel, I think, they don't have yeast in their bread, which means there is more zinc deficiency, and so if they only have Marmite, then because Marmite is extremely high in zinc. Yeah, and this is... Okay, forget about the Israel-Palestine thing. Zinc deficiency is a really big problem, and that's something that you might want to tell people about. And what if you wanted to make an explorable explanation about how zinc deficiency can affect you? Well, there's like so many different layers to it. Like, you might have to start... Okay, you start like backwards. You say, well, like, we've got these things called, like, try and make a simulation demonstrating how zinc affects your ability to learn, or something like that, or affects the society where people are zinc deficient. Well, society's full of people. People have brains. Brains are made of neurons. Inside of neurons, like, sorry, you don't need all the detail of this diagram, but like inside of neurons, you have like many different friggin' molecules. All of these molecules are linked to, like, they have these really complex short-term and long-term behaviors and interrelations with one another, for which you use like systems bio. Okay, we've gone from anatomy to neuroscience to this is called systems biology. This is from my field. This is called a zinc finger. There's a molecule called a zinc finger which interacts with DNA in a complex way. And when you hear about it, you're like, oh my god, how could you get anywhere without zinc? And zinc has this particular role within the molecule, and it affects the way that your body expresses the thing that's in its DNA. And DNA is just so important within the context of the cell. Sorry, it's because this is like this one thing here. Not my area is not this stuff. My area is this one thing here. Zinc can play the particular role that it has within the zinc finger because there's no atom that can replace... Well, maybe there is. Zinc does a special role and is able to have this special role within the molecule because of the specific setup of the electrons in its orbitals. So this is like physical chemistry or theoretical chemistry going all the way up to anatomy, and then maybe you even want to tack on like a simulation of kids within a classroom. How could you possibly express like the real world is so complicated, and biology is like this. Biology involves going up and down these different layers. Like you might say it's about different scale levels or different levels of scale. But it's not about that. It's about behavior. It's about like these different there are these different facts that enter your head, and you get a quite vague idea of them. But you kind of assimilate them into a great big system in your head. But it's not a proper formal system in the sense that we were talking about earlier. It's not a simulation like Parable of the Polygons, in which you see all of the elements of the simulation and you can see emergent phenomena. It's like there's these huge number of... Like, there's this simulation within a simulation within a simulation. There's all these facts. Yeah, it's not rigorous, right? It is not. If you stay at one level of it, then it's rigorous. And you can do something like make an explorable explanation about electron orbitals, or about systems biology, or about zinc fingers, maybe. Or about brains, or neurotic neurons. Wonderful explorable explanation. maybe you make an explorable explanation in which you simulate individual children within a class, and like some of them are bullying one another or something like this. But you won't be able to make a single simulation encompassing the whole thing. You will have to have some amount of like words. You'll have to have these vague facts that connect simulations to things that you notice in the world. And like this is so obvious to people who make explorable explanations. Of course you've got to use words to teach people things, but Jon Blow doesn't use words. And FET, well, you can learn things from simple simulations, but you couldn't learn why zinc is related to classroom bullying or ability to concentrate on what the teacher is saying. So an explorable explanation is models plus some kind of argument. And it's about maths, right? If you want to talk about something other than maths, you need these words. It's basically about maths. That's why this whole thing is interrelated. A simulation on its own is not enough if you're talking about science. To connect things to the real world, and God knows, if you want to start talking to a teenager about maths, or, well, to a member of the public about maths, you've got to start saying things like, oh, maths is super useful for, like, planning traffic and, like, understanding bits of biology and for, that's the way that maths outreach works. You've got to use words. You've got to go up and down the ladder of abstraction. You can't just like be like, oh, look at like these lines and these circles and play around with the lines and the circles. Isn't that fun? Yeah, it is kind of fun, but it doesn't really. It's not exactly headline grabbing, and it's not exactly. It's not exactly. It's not headline grabbing. It doesn't sustain people's interest. It doesn't grab people's attention. Maths on its own. Science does. That's the role of science, to connect the maths to the real world. And in the next things that I'm making, there are these things that you can use: words, photographs, videos. And when I say video, I don't mean like an animation video. I mean like a filmed video. These are things that are beyond your simulation, and I might try to sort of like make things where I like swear off these things. I'm not allowed to have any, like, if I make some simulation, if I can connect it to the real world without using words, photographs, or filmed videos, then I will try to do that. But this purity is very, very appealing. It allows you to be rigorous, blah, blah, blah. Okay. And I want to put this in a broader context. The context of all of art. You know, I have this thing up here, going from games to sci-fi novels. But like, that scale can keep going. The games would still always be the furthest things to the left, but you could go further to the right, and go beyond, and move away from simulated things, right? And what I'm really interested in, and what I've been interested in for a very long time, is art that talks about the truth. Here's some epistemology now, and of course there's a picture of, and a quote from Richard Feynman. What I cannot create, I do not understand. That's very close to this thing about Jonathan Blow. Writing the simulation, writing the system, and because you've got a compiler, it's biased towards producing truth. What I cannot create, I do not understand. He just threw that out there. There's a quote from Lord Kelvin, famous for various things, good scientist. When you cannot measure what you are speaking about and cannot express it in numbers, you know something about it. But when you cannot measure it, when you cannot express it in numbers, your knowledge is of a meagre and unsatisfactory kind. It may be the beginnings of knowledge, but you have scarcely, in your thoughts, advanced to the stage of science. Whatever your thoughts may be. And you get a clear... I feel like I get such a clear feeling for that when I'm programming a system in which my understanding is rigorously represented, and then I have to talk about that system. I have to talk about biology. I have to talk about brains. I have to talk about zinc deficiency in Nepalese kids or something like that. And there's a sort of even more extreme version of that quote by a guy called Mike Munger, who is an economist. Actually, it was quoted by Zach Wienersmith. I don't have a primary source for it, but it's a pretty good quote. Verbal theorems are just mathematical theorems with ambiguous assumptions, and that's so tough. That's a really tough thing to say. It sort of suggests that, like, when people just talk to one another, there's no guarantee that, well, okay, obviously when people talk to one another, there's no guarantee that they're right. If anything, like, when Donald Trump says something with his mouth, there's a guarantee that it's wrong. But, when you say something, when you make a truth claim with words, who knows what's behind it, what ambiguous assumptions there are. Not so with maths. Yeah, I believe all that. Knowledge is becoming more mathematical. Society is moving to a point where we take stuff like this more seriously. More people know what is meant by this, I think. And things are kind of being... I think this is a very interesting part of history. Two things happened very recently. This guy, Jeremy England, biology is just thermodynamics. He gave a lecture a while ago, I suggest looking up on YouTube, in which he sort of showed how, it seems plausible that biology can drop out of thermodynamics, which is incredible. It sort of shows how biology began. Like, one of the deepest questions in biology is how did living things start? And I think he's answered it. And it's about thermodynamics, and thermodynamics is this rigorously understood mathematical system. He says that. Scott Aronson, this guy, quantum mechanics is just probability with negative numbers. That's a very deep philosophical statement, and very interesting. And probability is a field of pure mathematics. Eliezer Yudkowsky, science is the whole of science, and scientific inference is plausibly just Bayesian statistics being another subfield of mathematics. Max Tegmark, this guy, in the same year as Jeremy England, Max Tegmark published a paper in which he sort of said, the multiverse is just an equation. It's one equation among many equations, and there's deep implications of that. And Kurt Gödel, long time ago, probably Kurt Gödel, if he would strongly agree with what Max Tegmark said, except for the fact, do you know what, I take that back, sorry. Kurt Gödel might strongly disagree with what Max Tegmark said, but Kurt Gödel was sort of, in my opinion, proved that mathematical concepts have a real existence, and he proved that in like 1930s or 40s. And finally, there's an aphorism. This quote we don't know who this quote is attributed to, but possibly it's something a bit like what Bertrand Russell said. But the mark of a civilized human is the ability to look at a column of numbers and weep. I am a big fan of the effective altruist movement, and I think that it could be really influential in the future of human thought, and that's a really cool thing there. Really beautiful idea there. And it sort of makes me feel like there's so much. So some people, it's a bit of a cliche to say everything is maths, but it kind of is. Yeah. And that's something that you can get at with our explorable explanations and mathematical art, whatever else you like. But other forms of media, prose, movies, whatever you like, they've previously had a kind of what I might call artistic truth. Getting very philosophical here, but you've probably seen this guy. This is John Keats. He said, "Beauty is truth, truth beauty. That is all ye know on earth, and all ye need to know." And that is not true. It is. It's something. It's a thing that you can tell yourself, but it's not the case because there's many beautiful things that are. Well, anyway, Werner Herzog here, he made some of my favourite films of all time. In particular, he made. I really like his film Encounters at the End of the World. It's possible that I wouldn't be in science if it weren't for that movie. But he is also a documentary filmmaker who plays fast and loose with the truth. It's so sad. So he has made up quotes. There's at least one quote that he's made up and admitted it. At least he admitted it. But so very inspiring as a creator of art, but very much towards the end of the spectrum where things can be wishy-washy and there's no guarantee that they're true. Keats, because he believed that beauty was truth, we know that he did like true things and he wanted to say true things, but he didn't care about them that much, actually. He used to say has another bit of poetry in which he complains about how science has disproved the existence of gnomes, which is kind of sad. Yeah. Why have I got this here? Oh yeah, like this is an example of something. Like so many people are like, "Oh, isn't it beautiful how like the golden ratio is in everything?" The golden ratio is not in everything, yeah, that's supposed to be a example of maths being wonderful. But yeah, many a beautiful theory was killed by an ugly fact, and if you examine these things closely, you find out that there's no correspondence. In particular, if you tell somebody in my field that beauty is truth, you're likely to get punched in the face. What I've got a picture of here, it looks quite beautiful. Yeah, I just got to have a little thing about this. Structural biology, which I work in, can be a total nightmare. There's this part of the process where you've got to crystallize a protein, and crystallizing a protein can take a very small amount of time, like a week, or it can take years. As I know a guy who has been, well, there's a person in the department who's been trying to crystallize a protein for 7 years. And science is so horrible like that. It's like that a lot. You get screwed over by the truth. And the rigor kills you. It's so tough. And you have these ideas and you're like, oh yeah, it would make sense if this and this and this, and then it doesn't work. Because Mother Nature just brings down her fist on your theory. And this is all quite personal. This is the lab that I work in, and this is my dad. My dad, he really likes Keats, but he's a journalist with the BBC, and he says when I would give him little essays when I was a kid, essays, not when I was a kid, when I was a teenager, right, for school, he like, your prose needs to be more dispassionate, more efficient. He really loved Keats, but he knew that he was wrong. Also, I actually went to university and did a course by this guy. This guy's Peter Lamarck, and he's very skeptical about all kinds of artistic truth. Even in so he's like, okay, he has lots of publications in philosophical journals about stuff like Pride and Prejudice or something like that. What is the actual insight that is dispensed by Pride and Prejudice? Really, by these films that I like too. I really like the films Magnolia and The Tree of Life. But what do they actually say? What are the truth claims that they make? Possibly nothing. And yeah. And for one thing, like, and when an artist, if there are lots of artists that like talk about cross-pollination between like the arts and the sciences, but if an artist sits down and really and when I came to this lab, working in real science shows you what it is like for it to be your job to discover things and to be certain about the things that you've discovered. And it's nothing like art. Mr. Keats. With the exception of a few things that I've got here. Sort of. These are a set of art forms that have a truth in them that's not dissimilar to the kind of truth that Jonathan Blow talks about being dispensed by games, or talks about like that thing that we were talking about earlier, where you have like the deathmatch shooter, and you know the truth that people got at was like, oh, there's this one part of the map that's like particularly dangerous. That's a thing that's true within that game. And there are art forms. So here I've got there's wonderful videos you can look up of people blowing smoke rings in really interesting ways. This is called the Balinese candle. There's dancing with candles, and there's very interesting things ways that they dance with candles, and it's related to something called the belt trick, and I'm going to be doing something about that soon. Fire spinning, the ways that you can weave fire, and like you see people do these things with their hands, and you're like, how is that even possible with like a human wrist? It's a surprise. It's a surprising true thing that certain movements are possible with the human wrist, and that there are certain ways that like swords can be entangled in a Morris dance, and certain ways that juggling can be done, and certain ways that the human body can fly through the air and manipulate its momentum when it's doing the high bar. It's maybe not a coincidence that Jonathan Blow is influenced by martial arts as well. And what's happening with a lot of these things is that there are sort of limitations on them. There are rules that everybody here is following, but you're surprised by what is possible within those rules, and you're surprised by what you might say the emergent phenomena that the people working within this medium have found. And these are very ancient things, ancient art forms that have been expressing truth for a very long time, more so than novels to a large extent. And they're just such wonderful mediums as well. They're things that anybody can enjoy. They don't use words, all right. Anybody can enjoy them. You can watch them being done outside, right? Because they were all done outside, you can't hear people so well. If they were to try to say something, you wouldn't be able to hear it. And you might call these things tricks, right? Like smoke tricks, the Balinese candle trick. But they're not tricks because you see exactly how they work. Yeah. And toys are another example of this. So nice videos here. You can look up Tadashi's Toys, Grand Illusions, Hexaflexagons by Hart. This is a video where Buckminster Fuller introduces something called the jitterbug. This is a video by George Hart in which you sort of see his hands making these interesting mathematical shapes. And yeah, toys are ages old, and they sort of explore these possibilities as well. Yeah. Slide together constructions is the name of this video. It could almost have been an explorable explanation. So I do recommend it. Yeah. Oh, and if you want to hear more of me talking about little toys, then there's a video I made called "What Do Origamists Have in Common with Viruses?" Yeah, they just present these wonderful, amusing things. I love these art forms because they don't make the audience do any work. That's not very Jonathan Blow-like. But yeah, they're never asking you to imagine something done, as a maths teacher might. They show you things being done. I want to end with one here. This is sort of my favourite. A guy called Tom Noddy. He has some music. I'm going to silence it. He works with bubbles. That's his chosen medium. There's another group of performers called the Yangs who work with bubbles. Tom Noddy, I believe, used to have words in his act, but he doesn't anymore. And he has, wonderful things like this. Like, all you're seeing here are like, the rules. The rules are things like bubbles are fragile. He's able to make bubbles inside of bubbles, and like, wow, I didn't know that was possible. Using his breath and using these 2 points of contact with the bubbles. For me, he's like in a sense, he's like one of the great. He's such a great artist. It's maybe a bit of a surprise to see him actually, touch it with his hand and it not burst. So, yeah, he doesn't need words. Why should we? Thought that I'll leave you with. Explorable explanations are a very rigorous expression of truth, and it's plausible that maybe one day humanity will dispense with other forms. I don't want that to happen, of course. Pride and Prejudice is a great book, and what novels are wonderful and movies are wonderful, but like among people who are asking for truth, like it's possible that I think that this is such an important time for the development of human communication. And there's this idea, there's another thing that Jon Blow sometimes talks about. Don't try to express things, try to point to things. Like, here's this thing. It's kind of like, maybe another example would be BBC nature documentaries. They just point a camera at some beautiful natural site. Like, you point at the thing and people get to see it. And they don't have to, like, follow your argument. Don't think of it that way. Just show things without words in puzzles. Show the importance of things. Show the reality of things. I'm saying a bunch of things that make very that don't make good business sense, I'll say. What I'm going to be doing is making these sort of puzzle things in which you see my hands manipulating stuff. But I'm going to have, and you play around with puzzles, but I'm going to upload them to YouTube as well. So reliance on puzzles as a mode of expression is a bad idea for me, but I want to do it anyway.